This is the Evo64, an all-new Commodore replica with an impressive array of high-end features, including vacuum tubes. I'm Matt D'Amico, and welcome to episode 76 of Retro Bits. When it comes to Commodore reproductions, we're absolutely spoiled for choice. There's everything from exact replicas like the 60 clone, modern enhancements like the C64 Reloaded Mark II and ICS64S, to fully FPGA-based solutions like the Ultimate 64, and many more in between. Let's see where the Evo64 fits into the picture, and take a look at some of the features that make this one stand out from the rest. And here it is. The Evo64 team has sent me this pre-release board so I can share it with you guys. Now, I opened it up as soon as it arrived because I just couldn't wait. It was like Christmas came early this year. So let's take a look at what they've sent. Okay, we've got a note here to Matt and the RetroBit team, and they've got the logo there. That's really nice. We really love the RetroBits channel, and we're super psyched that you're taking a look at our project. Evo has been our labor of love over the last year or so, and we're hoping that you have as much fun playing with it as we've had making it. And then they go on to talk about what they've included, and a QR code to a quick start guide, and then best from the Evo64 team, Dr. Stefano, Daryl, and Mario. Well, thank you very much, guys. I appreciate this opportunity to test this board out. And so, what we've got here, and they've sent a little keychain to go with it. Very cool. Evo64 from Oroscience Production. Let's take a look at what's inside. Wow, would you look at that? This is a work of art. It's absolutely stunning. This is completely modern, but still instantly recognizable as a Commodore 64. It's amazing. Everything on the board is labeled in silkscreen with what it is and how to configure the jumpers for your particular settings, and then high quality components are used throughout with these capacitors and ZIF sockets and adjustable pots there, as well as filter capacitors on the back here for the audio and video. Everything is just engineered to an exacting standard here. It's amazing. In the team's own words, the Evo64 was developed by Dr. Stefano, aka Oro, out of an interest to combine many of the best features that have become available for the Commodore 64 into a sleek and fully integrated system that can be built using modern manufacturing processes while still remaining completely true to the original system's heritage and architecture. The hardware itself is designed for maximum compatibility. It will work with any generation of VIC-2 video chip, 5 volts or 12, NTSC or PAL. The same goes for the dual SID audio chips. A modern surface mount design utilizes high-end components for heat and noise reduction, but still makes use of your original processor, video, sound, and I/O chips. The project came about after the team had already built a handful of other replica boards. In 2021, Peter Hans released the source to his 250407 clone to the world, and Dr. Stefano started playing around with the CAD files. He thought it would be cool to incorporate some of the best standalone enhancements the community had designed in recent years directly onto the board. Once he got started, this passion project really took off, and a continuous string of improvements and features were added. Over many iterations, the Evo64 matured into something completely unique. The project's website discusses the design philosophy and all of the features you'll find on the Evo. The board and each of its components are extremely well documented. Daryl Westbury can be thanked for that, as he's been in charge of developing the webpage, creating documentation, and hardware testing. Now, let's take a closer look at the features of the Evo64. First is support for dual SIDs. You can mix and match any variant of MOS 6581, 8580, or modern replacements such as ARM SID, FPGA SID, or Swin SID. The two sound chips can operate both in dual mono or 6-channel stereo, and the address of the second SID can be configured with jumpers. The Evo's integrated PLA has been designed in such a way that it can simultaneously listen on multiple addresses, D420 and D500 for example. This allows for maximum compatibility with software coded to make use of different SID configurations. It's also possible to select which of the two chips will be primary and respond to read requests and handle paddle inputs. Individual gain controls are provided to balance levels between different SID models, along with configurable output impedance resistors and filter capacitors. Something that sets the Evo far apart from other offerings is the relentless pursuit of the best possible audio experience. The board uses high-quality linear voltage regulators to deliver consistent, continuous, and predictable levels of power. Significant time and energy has been spent re-engineering the board to reduce unwanted noise. Dual independent audio amps using contemporary transistor technology are built in as part of the default setup. Perhaps the most unique and over-the-top feature of the Evo is the pair of optional tube-based amplifier modules that were designed to add warmth and character to your SID music, and this is where things start to really heat up. The first option is the NewTube64. Designed to keep power consumption and heat levels to a minimum, the NewTube 6P1 by Korg is a popular choice among audio enthusiasts, meeting the stated requirements while also being able to fit into a small form factor. Similar to a conventional triode vacuum tube, these devices are built using vacuum fluorescent display, or VFD technology, and emit a bluish glow when plate current is flowing. Each NewTube 64 module is hand-built, then subjected to a break-in period and fine-tuning by Dr. Stefano himself, a process that takes 2 to 3 hours per unit. The second amplifier option is the Triode64. This module implements 4 separate old-school vacuum tubes that will protrude prominently out of your Commodore like a steampunk fantasy come to life. As one might expect, this module has significant power and heat dissipation requirements. As such, it will need a custom power supply, such as this low-noise, audio-grade toroidal transformer unit built for this specific purpose. Audio isn't the only thing that's had a workover. Video too has been given the Evo treatment with the Clear Video 64C circuit, a complete replacement for the old RF modulator. A high-quality video amplifier provides excellent color and clarity, and a series of adjustable pots have been implemented to reduce noise and the jail bar effect the 64 is notorious for. Any model of VIC-2 can be used, even the brand new Kawari. Both NTSC and PAL crystals are provided, along with a modern clock generator that eliminates the legacy MOS 8701 chip and provides a stable, jitter-free clock signal. A nice quality of life improvement is the Multi-ROM implementation. This allows the use of a single EEPROM chip up to 1 MB that can hold 8 different kernels, 4 versions of BASIC, and 8 character sets. ROM configuration is performed by way of jumpers, but hot switching via key press combination is also possible with a separate module. In addition to the system ROMs, you can also store up to 64 cartridge images on the EEPROM, which allows you to bring your favorite games, utilities, and diagnostics with you wherever you take your Commodore. Everyone knows that the 64's programmable logic array, or PLA chip, is prone to failure and is the #1 cause of machines that won't boot. The Evo solves this problem by doing away with the MOS chip entirely in favor of what they call the QAPLA. This CPLD-based solution provides the tight timing tolerances required of the original PLA while adding support for the flexible addressing of the dual SIDs and configurable ROM and cartridge images. QAPLA has been extensively and rigorously tested, and the team is confident that it's on par with the best PLA solutions available. Also cool is that future updates can be delivered to the system using the included JTAG connector. Finally, electrostatic discharge protection has been built in on the Evo's joystick and I/O ports in order to prevent accidental damage to the increasingly rare and valuable MOS chips. A nice touch to round out an amazing set of features. Now, I think it's finally time to build our new, high-end Commodore 64. Of course, to complete our Evo64 build, we're going to need donor parts from a Commodore 64. And what we've got here is an assembly 250407, the same board from which the Evo was originally designed, and it contains the necessary VIC-2, CPU, and CIA chips that we're going to need for this build. Now, this board was sent to me by Mitch Hoffman, another Commodore 64 enthusiast and YouTuber, and he included this note. Matt Retrobits, please find enclosed your C64 motherboard and keyboard for parts. I sincerely hope these supply you with all you need to complete your Evo64 board build. He goes on to say it was written with a 1950s fountain pen, another hobby of his. Really amazing handwriting, Mitchell, and thank you very much for sending me in the parts I need to complete my Evo build. So let's get started. Now that we've got our chips extracted, we can start to populate the board. But first I wanted to show you guys this. This is the Getting Started guide, Welcome to the World of Evo, and it covers all of the steps that we're going to need, the jumpers and things to look out for. So we'll be following this step by step, just part of the great documentation that I mentioned for the system. So hats off to you guys. Thanks, Daryl, for putting together that excellent documentation. You may have noticed there are some very small surface mount components on this board, but don't worry, those will be pre-installed from the factory. All that you'll have to do when you build your own Evo is to do the through-hole components such as these sockets here. Now, the estimated time to completion from start to finish is around 2 hours to build this board, so it's not a huge lift. These sockets and all the other components were installed on this pre-release board for me, so I don't have to do any soldering here, I just need to add the chips. One thing to note is that with this board pre-installed with these nice ZIF sockets, some of them are oriented in this direction and some are oriented in the other direction for clearance purposes. They do cover up the silkscreen showing the orientation of the chip and where pin 1 is supposed to be. In this revision of board, pin 1 is always towards the back or the I/O portion of the board, so pin 1 will always be here regardless of the orientation of the ZIF socket. That said, let's get this thing populated, and I will start with the 2 CIA chips. Now, these are the complex interface adapter chips. These handle I/O, so keyboard, joystick, disk drive, serial port, all of that stuff is handled by these 2 CIA chips, and these are MOS 6526R4 chips. There's one. There's 2. Okay, next up we've got the 6510 CPU. We've got the 2 SIDs, we'll come back to those in a minute. And then last we've got the VIC chip, and for this we'll be using a 6567R8 VIC2. And there we go. All right, let's look at the SID chips now. This board, of course, accepts both 6581, 8580, and any replica SIDs like ARM SID or FPGA SID, Swin SID, anything like that. For the purposes of this build, I will be using 2 8580 R5 chips. And I've got one here that's from MOS, dated 1287, and then another one from CSG, dated 37th week of 1989. They're both revision 5 chips, but they're 2 years apart. MOS became known as CSG, the Commodore Semiconductor Group, and that name change was effective in 1983, but they didn't start labeling the chips CSG until 1989. And there we go. The next thing we need to do, per the Getting Started guide, is to set the SID voltage jumper here. And you'll notice that it's set to a neutral position. It's not set to either direction. That's because a 6581 needs 12 volts and an 8580 needs 9 volts. And if you put the wrong voltage into this chip, you can fry it. So we don't want to do that. We need to make sure we have this set to the right setting. So we'll go 9 volts for our 8580 chips. I should also mention that there are two sets of jumpers because you can mix and match SIDs. You don't have to have two of the same. In fact, if you use an 8580 and a 6581 in combination and have them mirror each other, you can get a stereo effect where the two different chips sound different, so you get kind of a fuller, richer sound. Now, it may be good, it may be bad, depending on the track that you're playing, your personal preference, and how well the chips kind of work together. But in this case, we're going to be using identical versions so that we get a nice stereo sound from stereo SIDs. Same story with our VIC-2 chip. Older 6567 and 6569 series need 12 volts, and the newer 8565 and 8562 chips need 5 volts. So we've got the earlier 6567 R8 chip here, so we'll need to make sure that we set this to 12 volts. Now you can also use the brand new VIC-2 Kawari chips here, and it's been tested to work and to fit on this board. So maybe I'll try that in the future. Next, we need to set the video timer on the clock generator circuit for NTSC or PAL, depending on which chip we use. It's as easy as flipping a jumper and changing out your VIC chip, or if you're using a Kawari, you can switch back and forth. We're using an NTSC chip here, so we need to make sure that we've got these set for the NTSC position. You can't damage your system if you get this wrong. It simply will not boot if you have the wrong oscillator settings. So we've got the right settings for NTSC, we should be okay. The next step of the guide is to set the SID filter capacitor settings. For 6581, you do not use external filter capacitors. For 8580, you do enable them, and they are already enabled on this board. If you get it wrong, it's just not going to sound very good. It's not going to damage the system. It's also worth noting that if you have a reproduction SID here, they don't use external filter capacitors, so you would leave these jumpers open. They're already set, so we're moving on. Next, we need to set the SID1 potentiometer resistor setting. Now, this is for the paddle and mouse input, and for 6581, these need to be open. For an 8580, they need to be closed. They are already closed, so no change required there. Next, we need to configure the stereo SIDs with this Evo Mix SID block of dip switches. The first switch determines whether we're in stereo or parallel addressing mode. When it's in the on position, we are in stereo mode, so the chips will be addressed separately. The second switch determines which of the two chips is going to be in read-write mode, and this matters if you have a 6581 and an 8580. Software will detect which of the two chips you've selected is in the system, and it will also use the potentiometer input for the mouse and paddles of the chip you select here. Doesn't matter when we have two identical chips. 3 and 4 determine which address the stereo SID will listen on. In this configuration, it will listen simultaneously on D420 and D500, and if we flip them into the other position, it will listen to DE00 and DF00. And this matters for certain pieces of software that are hard-coded to use one or the other address. But I'm going to leave it in the default setting for now. So that's it for configuring our board. You'll notice that we have the optional NewTube64 module pre-installed on this board. If this wasn't there, there would be some additional jumpers and some potentiometers to balance out the two different SIDs using the on-board amplification circuit. As we have the external amplifier here, we don't need to set those settings. This board has already been fine-tuned by Dr. Stefano himself, a process that takes 2 to 3 hours per board. So we will be putting this NewTube64 module through its paces a little bit later, and we'll also take a look at the Triode64 module in a bit. Now that our Evo64 is fully configured, it needs a proper home. I've been saving this for a special occasion, and I can't think of a better use for it than this. Oh yeah, that's gonna look so good in there, showcasing that lovely Evo64 board and the glowing Korg NewTube module right there. All right, let's get this thing fitted. Oh, first problem. The standoffs don't line up with the holes in the board, and that is because, yep, take a look at this. The joystick ports have standoffs on them which conflict with the case. They don't pass through, there's no hole for them. So I'm going to need to remove those standoffs and install a low profile kind of flush screw to hold on the joystick port. So let me do that and we'll be right back. All right, I've swapped out the standoffs for some low profile screws that have the same thread pitch, and so that'll hold that in there properly. Let's see if it fits now. Oh yeah, perfect, perfect. Fits now just fine. All right, let's get the rest of this together. Okay, ran into another problem. On a longboard 64, when you're mounting it in a 64C case, you need to use these brackets to mount the keyboard. And the left bracket seems to work just fine, but the right bracket, it installs here and kind of straddles the joystick port, but it has this metal foot that sits right on the board. And not only am I worried that it's going to scuff the board, but it also looks like it's going to short out the legs of this ESD protection circuit here, and I don't want that to happen, so we're going to need to do something about that. Now, I do have some 3D resin printed parts, courtesy of friend of the channel, Justin. These are a different geometry though, and if we look at how it mounts, the foot wants to go right where this big capacitor is, so that's not going to work. I either need to redesign and reprint a new 3D printed part here, or modify this somehow. And I think what I'm going to do temporarily is just cover up the landing pad here with some electrical tape so that it will not short anything out as a temporary solution so we can get this build done. And then later on, I will modify the 3D printed part. Yeah, so using electrical tape is not my first choice here, but this is a temporary solution and needs must. So let's get this done, and so we can test the board now, and then I will address this situation a bit later. But that should do the job such that that little foot isn't shorting anything out. None of the screw holes in this brand new case come threaded, so they've provided these self-tapping screws that we have to put in. It's a little scary running these in for the first time, but let's try to keep it straight and do the best job we can. All right, next thing we need to do is install a keyboard. Now, the keyboard that we're going to use was also sent to me by Mitchell, so thank you, Mitchell, for this keyboard. It's going to be a great donor. This is not the look that I was going for with this build. My Indiegogo keycaps shipped 3 weeks ago, according to the notification I got, but there's been no tracking update since then. So I am waiting for those lovely translucent blue and red keycaps to come in to help complete this build. I think they will look amazing in this transparent case. But for now, I'm going to have to use what I've got, and then we'll update the look at a later time. Yeah, I think that's looking pretty good if I do say so myself. I am not going to put the top cover on right now because I'm going to need to access some of the jumpers and some of the dip switches to set up the kernel and ROM settings, and in case anything isn't right when we power this thing on. So I'll leave this off for now, but I think this is going to look really, really good, especially once these keys are changed out to match the overall aesthetic. That is just an awesome looking board though, isn't it? Peeking out from there. I can't wait to fire this thing up. And speaking of firing it up, I think we're ready to go. There's nothing left to do but flip the switch and see what happens. So here we go. Hey, would you look at that? We have a working Commodore 64. Nice. All right, now let's take a look at some of the features and see how the Evo64 performs. The first thing I want to do is take a look at this 1 megabyte EEPROM and check out some of the images and kernels that are stored on here. And to help with that, I've printed out this handy dandy table from the online documentation that shows where in the address space the various kernel, basic character sets, and different cartridge images are, and what the jumper settings are to access them. So let's start by trying out some of the different kernels. There are 8 different kernels to choose from, controlled by these 3 dip switches here. So all we have to do is flip one of these to a different position, and we've got a different kernel to try. And there we go, different kernel. We've got 8 slots we can work with, so you can put whatever you want in here. The original ROM, you can put Jiffy DOS, Jaffe DOS, Dolphin DOS, Speed DOS, you name it. Similarly, if we want to change the character set, we can adjust these 3 dip switches here. So let's try out the MSX character set and see how that looks. Hey, it works. That's pretty neat. I don't think I want to keep it that way, but it's nice to have options. In addition to the ROMs that we put on this EEPROM, we can also put cartridge images. The same dip switches are used to select a slot, but we have to flip this jumper on the JTAG block to tell the system that we want to boot a cartridge. Hey, and there we go. The first cartridge image on the EEPROM was the C64 diagnostic cartridge. Since we've got that running already, let's plug in the harness and run through a full diagnostic of the system. All right, I've got the full diagnostic harness connected. Let's flip this thing on and see how it does. All right, we have a fully functional Commodore 64. Nice. There are a total of 32 slots for cartridges on the EEPROM, and all we have to do is select which one we want. Just like that, we've got games, utilities, diagnostics, you name it. So the next thing we'll look at is the Clear Video 64 circuit here, which provides us with these 5 potentiometers that allow us to tweak the video output to look better on our display and to have sort of the characteristics we want. Now the process is relatively in-depth and there's a number of steps that you follow. Then you iterate over and over again in order to get the clearest video. But what I'll do is I'll show you a quick demonstration of a before and an after. So let me get zoomed in on the screen. So here we go. I've got the camera focused on the LCD panel. Now this Dell has a particularly crunchy NTSC input. It always looks a little bit fuzzy, a little bit, flickery, no matter what, but I've got S-Video connected here and you can see the characteristic jail bars that are common to the VIC-2. And what we're going to try and do with these pots is eliminate those jail bars. So I'm going to turn them now and pay attention to the screen. Yeah, and just like that, we've eliminated the jail bar effect with just a few tweaks. Now, the process is going to take a while to fully iterate through all of the settings to get the perfect image, but I'll do that now and then we'll come back to the system and look at some other features. All right, I think it's finally time we tried out the audio capabilities of this thing. And for that, we're going to want a PAL machine so that we have maximum compatibility with demos and stereo SID music that's out there. So let me show you how easy it is to convert this NTSC machine to PAL. First, we'll just get the keyboard right out of the way. Next, we simply remove our NTSC VIC2 chip, just like that. We'll get out our PAL chip, just like that. Now this PAL chip I'm using is an 8565 R2, and that is a 5-volt chip as shown here on the silk screen. So we need to make sure that we move our jumper to the 5-volt setting, not the 12-volt setting. And then all that's left is to take these two jumpers that are in the NTSC position and move them both down to the PAL position. And now we have a PAL machine. Easy as that. There are a number of options for getting stereo audio out of a Commodore 64. The one we're going to look at today is this. It's a little breakout board and it connects to the AV port on the back. This was donated to the channel by Kevin Gonzalez. Thank you, Kevin. It provides composite left and right audio, S-video, and an 1/8" headphone jack, and it's all configured through this jumper block here. You can either mirror the single SID on both ports, or you can split out the left and right SID onto these separate channels. In order to do that, you have to use one of the unused pins on the 8-pin DIN connector, and we'll look at how that works with this system in a moment. On the underside of the board, there are solder pads where we can select which pin we want the second SID's audio to be connected to. I'll bridge the pads for pin 7, which is the one I chose on the AV Breakout's jumper block in the previous step. An alternative to the breakout is to make or purchase a stereo cable that uses either pin 5 or 7 for the second SID, as demonstrated here in the Evo's documentation. If you have one of the optional amplifier modules like this NewTube64 here, you have another option for stereo out, and that's right here on the back where the RF channel select would normally be. There's another 1/8" headphone jack, line out jack here, and if you'll notice mine doesn't quite align with the case, that's because I've got 8mm standoffs here and I really need to use 6mm standoffs. So I don't have any of those on hand, but when I order the correct part, that will bring the port back into alignment, and I'll be able to use that for my audio out as well. I'm sure by now you all want to know what a Commodore 64 with stereo SIDs and a tube preamp sounds like. Unfortunately, I can't demonstrate it for you. Any audio I record will be digitized, compressed, transcoded by YouTube, and played back on whatever device and speakers you're using to watch this on. You've really got to be here in person. So, you're going to have to take my word for it. The Evo with NewTube module sounds amazing. It's unlike any 64 you've ever heard before. The music is so much warmer and richer. Every note is so much fuller, especially the low frequencies you didn't even know the SID could produce. If I'm honest, it's hard to believe that a 64 can sound this good. I'm no audiophile and I don't have high-end equipment, but even so, I'm blown away by the difference. Heads up, a modern power supply is going to be needed for both line noise reduction and to provide enough juice to operate the NewTube 64. A C128 supply might do in a pinch, but the increased background noise was immediately obvious when I tried using mine. trimmers are available that allow you to adjust second-order harmonic distortion with the aid of a voltmeter. Depending on whether you go up or down, you'll get a deeper soundstage and magnified illusion of instrument placement, or you can tune for an up-close, more intimate and detailed experience. The Triode64 and custom power supply have been tested and are working, but they're still in development, so a demo unit wasn't available at the time this video was filmed. The 4 tubes require 24 volts DC and will demand 24 to 36 watts of additional power. The module is reported to sound even better than the new tube, but the barrier to entry is also quite a bit higher. I guess that means we should talk about the costs then, huh? While the price and availability aren't finalized yet, an Evo64 with all of the surface mount parts already in place will run around $285. Figure another $55 to source all the through-hole components, and you'll also need to supply your own MOS chips. More than other replicas for sure, but quality of this type doesn't come cheap, and this is not a mass-produced product. Now for the real sticker shock, so brace yourself. If you want one of the new Tube 64 or Triode64 preamp modules, you're looking at around another $500 or $1,000 respectively. Before you take to the comments section, keep in mind that you're not just paying for the design and parts. Each unit is built by hand, and the JFETs are selected one at a time for optimal drain current. Each unit is then subject to a break-in period and final tuning. The result is the absolute pinnacle of C64 audio available today, and as such is geared towards serious audiophiles and SID enthusiasts. So there we have it, the Evo64, an impressive modern recreation of the beloved Commodore 64 that minimizes its shortcomings and maximizes its strengths, all while staying true to the original architecture and heritage. If you're an audiophile, musician, or serious SID enthusiast looking for the best possible C64 experience, this is for you. Follow the Evo progress on Lemon64 and Facebook. Links are in the description. Thanks to Dr. Stefano and Daryl Westbury for loaning me this pre-release version to share with you all. Don't forget to like, subscribe, and leave a comment. I hope you enjoyed this bit. Thank you so much for watching, and see you next time.